Okay, student, let us uh, start the topic projectile motion. As we are going to start the projectile motion, let us see the examples as I am showing in the figure that how the curvy nature of the water falls as you saw seen here. Okay, first of all, let us see the definition. Then it will be very clearful. Okay, moving to the next slide. Projectile motion is a motion in which an object is thrown near the earth surface. Here, earth surface is very important. Okay, and it moves along the curved path. Curved path means every distance on a circle states the curve path. An example which I can say, normally in ellipse, parabola, or whatever the curve things represent the uh, what I want to say that any path on a circle state the curve path. Okay, it moves along the curve path under the action of gravity only. Gravity should be there. If it is happening in the space, then there is no gravity. Suppose you are throwing a ball in a space and there is no gravity at all, then ball will move in a rectilinear path or in a straight path. No projectile motion is seen there. Okay, let us see an example, then it will be very clear for you. Okay, as you see in the figure, motion of a snow border descending from a slope. This is the slope, which is something height. As you can see, it is 2 meter. Okay, this skateboard, and this is the boy. How the motion takes place? As you see in the figure, it is happening. First condition, near Earth surface. Second, second part, under gravity, and that's all. These two conditions are mandatory for it to be a projectile motion. Okay, motion of snowboarder descending from a slope. Descending means falling down. Okay, this is also taking place of a parabolical path. Okay, let us move to the next slide. Same example, same way. This is the also a some height and having a some speed of, let us see, 100 km per hour. This biker has a speed of 100 km per hour so that to reach on this point, okay, safely. The path traced by the biker is shown here. As you see it, this is also a parabolical path. Okay, the motion of a rider performing a bike stunt. Those don't focus on the bike stunt. See how the uh, motion, see the path traced by the biker on a surface area, not on a surface area. In a 2D plane, you'll see the path of the biker. It will be a parabolical. Normally, it's in a space. So here we can also trace the path of a biker. It is a parabolical. Are you getting my point? Okay. Let us see some more other examples also. Ah. Motion of a water just coming from out of a nozzle. Suppose this is in a fountain. The water eject and the path traced by the water is a parabolical. All the water nozzles perform a parabolical path for water. Okay. See some more examples. Okay. The condition of a projectile should be air negligible air resistance, otherwise the path will be not a parabolic condition. Okay. The effect due to curvature of earth is negligible. Negligible means the earth of radius is assumed to be tending to infinity. It means the surface of earth is totally flat. You are getting my point? The effect due to the rotation of earth is negligible. And moving onwards in the next chapter, you will be seeing the effect of rotation of earth. Suppose this is earth and it is moving by omega, then the different points have the different value of omega due to no, not different omega but different uh, what you can say gravity due to this omega. Omega is the speed rotation of earth. Okay, the acceleration is due to gravity over a range of motion, means gravity should not vary. G should be constant for a constant parabolic path. You are getting my point over a range period of its motion. Suppose this is taking a 10 second, then G should be constant, not vary for 10 second. After that it can be vary or whatever things, but the duration of motion it should be constant. Okay. Okay, let us move forward. Okay, this is the normal example of parabolic. I am also showing the other projectile motion also. Suppose this is the building and you drop a ball. This is also a parabolic. Let us take another example. Suppose this is inclined. This is a wall, and from here you are throwing a ball. This is also a parabolic. Okay. Huh. And one more, what you can say. Huh. First example, second example, and this is the third example. Suppose you are kicking a ball from a ground through an angle theta and with velocity v. So its path should be a parabolic and the condition are there. This is the what you say range range of a ball which we can throw our kick. Okay, and this is the amplitude. What maximum what height goes the ball goes up. Okay, and this is the velocity. Hmm. Okay, let us move forward. This is the example you are getting. An object which is projected in the air is called as a projectile. An object which is projected in the air is called projectile. This path traced by the ball is a projectile path. Okay, and this is the amplitude and range. It will be very careful when you see the equation of the velocity. Okay, okay, let us move forward. Then it will be much more clear. As you know very well, this is the point of projection. This is the ball. The point from no, this is here only mentioned the point of projection from here you kick the ball. Okay, initial velocity. Suppose you hit with the 10 meter per second. Then the velocity of projection is 10 meter per second. You got it? Okay. Angle of projection, it is very clear. Path, very well. Trajectory. As you see in the, wait a minute. Okay. As you see in the diagram, the duration of a ball from here to reach here is time of flight. Okay. And one thing, the time taken by ball to reach from ground to its maximum value will be T naught by 2 here. The box goes to maximum, first goes to maximum, then maximum to minimum point. You are getting how what will be the time taken to reach from 0 to its maximum value? It will be 2 by 2. And from maximum to minimum value, it is against T by 2. Then total of time of flight is T. Okay. Maximum height attained by the ball. It is the maximum vertical distance traveled by the projectile from ground level during its motion. Everything is clear, I think so. The path moved by the ball from on a projectile path reaches to maximum from 0 to max and from max to minimum. Okay, okay, let us move forward. This is the horizontal range. I already mentioned there the maximum distance reached by the reached by ball when you kick the when you kick the football. Okay, okay. Is horizontal and vertical motion are independent? Both. This is the question mark. First of all, very clear about that. Both pink and yellow balls are falling at the same rate. Yellow ball is moving horizontally while it's having no effect on its vertical motion. It means the horizontal and vertical motion are independent. How? Suppose this horizontal velocity have Vh and vertical velocity Vv equals to 0. And here also the vertical velocity is also 0. Suppose you are getting my point. Horizontal velocity is something let 10 meter per second. Okay. And here also the vertical velocity is 0 and here also vertical velocity is 0. The ball moves with the same rate and reaches at the same round on same time period. You are getting my point? So there it means horizontal and vertical motions are independent of each other. Okay? Angle diagram of kicked football. This is the theta and this is the velocity by which you kick let 10 meter per second. Okay? ऐसा kick मारे the ball is traveling through a projectile motion. It will reach to a maximum value h and range should be r. So through equation you can easily able to solve the get the value of h and get value of r. Okay, analysis of projectile motion and vertical motion. Let us see. Suppose you kick the ball, or let us suppose this is a velocity 10 meter per second through an angle theta. You got me? Sorry. Then its horizontal component will be 10 cos theta. Wait a minute. And vertical component should be 10 sine theta. Now you can easily get the position of a football on any time. Like if you want to get what is the value of distance traveled by the this football, what is its coordinates, you can get x comma y also, coordinates also. Okay, and whatever other things you can easily get, you can get the maximum height also, maximum range also. Okay, suppose if you want to get the height of a football reached by here, then the vertical velocity should be 0. Suppose it has been started from 5 meter per second. It is going against the gravity. Then it somewhere on the top it will going to be 0. Get the distance from here from the Newton's law of equation. What I am saying? V square is equal to u square plus 2 gs or V is equal to u plus gt or s is equal to ut plus half gt square. By applying this formula, you can easily get the maximum point. Time also you can easily get. Okay, if you first of all break the velocity in its vertical as well as an in horizontal component. Okay, then it will be very easy. Okay, same here also. See, the velocity has broken into its horizontal and vertical component. Okay, this is Vx and this is Vy. Suppose how to get the range. Suppose the vertical velocity has started from 5 microsecond and it reaches to the top in a given time period t. Then it's again come back to 5 meter per second. Here the velocity is 0 meter per second. Okay. Then the times taken by going up and going down is total time is t, and the horizontal velocity does not accelerate or decelerate, it is constant. You are getting my point? Then the range is equal to Vx into total time. You can easily get it. Okay. Earlier you have find the amplitude, not amplitude, the height, and here you got the range. What is the velocity here? Suppose in a question asked, what is the component of the velocity here at the maximum point? Then what you say? No vertical velocity. Vertical velocity is zero. Sorry. You are getting my point? How it is zero? Because the value to the maximum value when the vertical velocity is goes here, it reaches when it reaches to its maximum value, its value becomes 0 meter per second. And what remains? Only the horizontal velocity. Okay. So on the top of maximum height, there is only one thing remain, that is horizontal velocity, and vertical velocity. V vertical is equal to 0 and Vs is equal to as it remains. Okay, let us move to the next slide. Same way, the here I want to get the direction as well as the magnitude of the velocity. Suppose here you are getting 3 points in earlier direction you have seen. Same way, the horizontal velocity remains same for total time duration, no change at all. Okay, let us resume. As we are seeing that ball is moving from from maximum height to its ground. The direction of velocity also get changed, but the component of velocity like horizontal as well as vertical, as you are seeing, the vertical velocity gets reversed, not the horizontal one. Initially it was going this way up, and now the velocity is going downward, vertical velocity, and horizontal velocity remains same at it is. Okay, now it reaches to the ground. What is the direction of velocity v? That becomes opposite here, same way, like anti, same way, and the angle remains same, not a not angle does not change. Okay, like vertically opposite angle, as you have seen, this is the theta, then this is also the theta, vertically opposite angle. As you are getting my point, now it has been cleared what is the direction of velocity at a crucial point. Like four cases we have as seen earlier, from starting, end, at the top, at the middle, somewhere. Okay. Now move to the next slide. Okay, it has been clearly mentioned. The horizontal velocity remains same. Only the vertical velocity gets changed. See here it becomes zero here and here. The horizontal remains the same. You are getting my point? Let us move to the next slide. Important conclusion. We are coming to the point on a conclusion that projectile motion is a combination of two motions. Horizontal motion with a constant velocity, it does not change. As I have earlier mentioned that it does not change. Okay, a vertical with a constant acceleration. Z is working on it. Okay, as I have already mentioned, break the velocity in its component. Hmm. Now comes to the point of the equation of trajectory. Okay, what is the path of the equation that is followed by the football? Write the equation of this. Okay, as you know very well, the horizontal velocity remains constant. Okay, then the distance traveled by the football on a horizontal axis is x into the time given. Okay, then the, as you know, this is the velocity, then this will be v cos theta. If it is theta, v cos theta, you got it, distance traveled v1 cos theta into t, and t is equal to x by v horizontal in v horizontal. Okay, velocity of component in horizontal direction. Okay, and now comes to the vertical side, traveled by the projectile in a time t along y-axis. Y is, yeah, here it is showing v vertical. Vertical velocity. Vy, as you know very well, s is equal to u2 plus half at square. Okay, y is equal to, and direction of v is forward up, and g, gravity of direction of g is negative. So it has been already taken the precaution that positive and sign changes, as you know very well. Y is v ut, initial velocity, into time given, half gravity due to acceleration, and t square. Substituting the value of t from the equation first, from here to here, we will get v of y is equal to vi sin theta cross x by vi cos theta minus half g x by vi cos theta का whole square. Now you comes to the get the relation. Suppose this is y, this is x. Then here y, x and x. You are getting the relation between y and x axis. If you put the point of any value of x, then you will get the value of y, like x comma y coordinate. Okay, this is the equation of trajectory of projectile. As vi, theta and g are constant for a given projectile, we can write tan theta is equal to alpha and beta is equal to this part. This is a beta and this is a alpha. And y is equal to x minus b square. This is a quadratic equation. You know very well the quadratic equation, same as parabola. This is the same as this is a projectile. You can say quadratic equation is a parabolic path. Okay, let us to move to the next slide. Okay, the distance traveled by the projectile in time along y-axis. Y-axis means in this direction, means above, up, and this is the range, as I already mentioned. Okay, for entire motion, t is equal to t and y is equal to 0. Okay, the total distance traveled by the football is, it goes up and once come back. You are getting my point. Football travels from here to here, start from the ground and reaches to the ground also. Then initial state in vertical position is 0 and final state in vertical position is also 0. So v1 sin theta t minus half gt square is equal to 0. Then half gt square is equal to vi sin theta into t. T is the total time period taken by the football to reach its destination. Okay, half gt square is equal to vi sin theta into t. From here we can the period of projectile. This is the equation of time of flight. For a symmetrical parabolic, the time of ascent is equals to time of descent, means going up and going down is t by 2 and t by 2. You are getting my point? As I have mentioned here, t by 2 and t by 2. For time for a ball to take to reach its maximum value, it is t by 2, and same way from here to here It is t by 2. Okay, let us move to the next slide. Here it is very clear of getting the time period of duration, time period of flight. Okay, the equation for horizontal range. In the diagram, it has been already mentioned what is the range. Okay, wait a minute. Okay, equation of horizontal range. How can you get the range of a projectile? Suppose the equation of trajectory of a projectile is given by y is equal to tan theta. This is alpha and this is the beta. You know very well. For entire motion, y is equal to 0. Y is equal to 0 means the initial upward movement and final state in vertical position is y equal to 0. We can put the value of y here equals to 0, and this is the quadratic. Quadratic means the value of range should comes at least 2, not at least 2, not a single one. Maximum minimum 2, minimum 2 r. It is the power of r square. Then you can get two values, either equal or 0 or two different value, distinct value, as we have solved in the quadratic equation. Okay, then first of all, r equal to 0. This is the one, and the next one, this is the next part. R is equal to vi 2 sin theta cos theta divided upon g. This is the next value of range. The range should be here 0 and other should be its this one. As we are seeing in the picture, it has been mentioned r is equal to v square by sin 2 theta upon g. This is the equation of horizontal range. For a given velocity of projection, the range will be maximum when sin 2 theta is equal to 1 and 2 theta is equal to 90 degree, then theta is equal to 45. For maximum range, the angle of velocity should be 45 degree. This one. You will get maximum range. Okay. The range of projectile is the projected in the direction of the maximum of 45 degree. As we are seeing, the maximum range will be at which angle? That is 45. Okay. Two angles of projection for same horizontal range. Okay. Suppose this is 45. Earlier I am saying this is the 45 at maximum. Then plus theta and minus theta, having the same equation of range. Okay. How? Let us see. The equation of range is given by r is equal to v square by sine 2 theta, replacing theta by 90 minus theta. R dash is equal to theta is the angle of velocity and this is 90 minus theta. The range equation is, as I have shown you, v square sine 2 theta upon g. Theta is 90 minus theta. R dash is equal to V square sine 2 90 minus theta upon G. R dash 180 minus 2 theta. As you know very well, sine 180 minus theta, then sine theta only. There is no difference in the value. Therefore, R dash becomes V square sine 2 theta upon G, and this one equal to R dash. As I have mentioned here, equation first and second have the same equation. R is equal to R dash. The horizontal range of projectile is same for any two complementary angles, theta and 90 minus theta. Okay, so from suppose this is the 30 degree and not 30 degree, this is 30 degree and this is the 60 degree. 30 degree as well as 60 degree both have the same range. Okay, let us move to the next slide. Equation for maximum height. Okay, maximum height means this portion. Let us see the equation, then it will be very clear. Okay, the third kinematical equation for vertical motion is v square u square minus 2as. Don't be confused. This is Newton's law for maximum height. For at a maximum height, you know very well, the vertical velocity becomes 0. You know very well the vertical velocity at maximum point becomes 0. Then at maximum height, Bfy is equal to 0, y is equal to h, s is equal to h. Then you are getting v1 sine theta square vertical component. 2gh is equal to v1 sine theta square, h is equal to v1 sine theta upon 2g. So for sine theta will be maximum when it is 1, theta is equal to 90 degree. What you say? The angle of projection. This is the equation of maximum height. What you get, and it will be maximum for at 90 degrees sine theta is equal to 1. You can put the value of angle theta and check the value of each case. This theta is equal to 30 degree, theta is equal to 60 degree, theta is equal to 45 degree, and 90 degree. 90 degree means straightly you are throwing. It is not a projectile. It is not a projectile. A straight line throwing at a 90 degree. It is not projectile. Okay. This is the till here. We will wind up in. We'll solve some question in next lecture. And that will be very helpful. Okay. So thank you.